NASA's James Webb Space Telescope has hardly awakened, and the universe is presently more cryptic and more exquisite than humankind's dreams. This enormous number of little specks are stars, this large number of little touches are galaxies, some of which are more prominent than our own. Spilling the beans, we could have recently found possible evidence of intelligent life beyond Earth. This is a huge discovery, and we imagine that a gigantic revelation is the most exciting part of this telescope, this magnificent instrument we've placed in space, finding things that we didn't expect, things we can't figure out. That means we have to rethink our understanding of the universe. The James Webb Space Telescope, JWST, is so extraordinary that, given enough time, you could probably find any system that ever formed in the universe. It's really that powerful. Pluto and its orbital mystery. Pluto is a distant and enigmatic planet that was once considered part of our nearby planetary system. However, recent remarkable declarations by leading astrophysicists Neil deGrasse Tyson and Michio Kaku have brought Pluto back into the spotlight with a stunning discovery. They propose that this chilly world is on a potential collision course with Neptune. But how could this happen, and what might be the consequences of such a massive event? Are we witnessing a fascinating cosmic anomaly, or is there more to this impending celestial disaster? Join us as we explore the potential outcomes of a Pluto-Neptune crash. Pluto, a former planet now classified as a dwarf planet due to its unusual orbit, remains a subject of interest in the astronomical community. According to recent estimates by leading scientists, Pluto's orbit is dangerously close to Neptune's. Astrophysicists Neil deGrasse Tyson and Michio Kaku are both raising the alarm about a potentially hazardous collision between these two celestial bodies, which could pose a significant threat to Earth. Understanding Pluto's orbit. Pluto's orbit around the Sun is unlike that of any other planet in our solar system. It takes an astonishing 248 years to complete a single revolution. Since its discovery in 1930, it hasn't even completed one full orbit. Pluto's orbit is marked by its highly elliptical shape, diverging significantly from the nearly circular orbits of the major planets. What makes Pluto's orbit even more unique is its inclination of 17 degrees to the ecliptic plane. This extreme tilt adds complexity to its orbital path. One of the most intriguing aspects of Pluto's orbit is its intersection with Neptune's orbit. For about 20 years in each orbit, Pluto actually comes closer to the Sun than Neptune, defying what we might expect from their positions in the solar system. This raises a natural question: why hasn't Pluto collided with Neptune? The gravitational dance. The answer lies in the gravitational effects of other planets. The study of Pluto's orbit began soon after its discovery. Initially, astronomers struggled to understand its peculiar trajectory. Unlike other planets whose orbits lie relatively close to the ecliptic plane, Pluto's orbit stood out with its steep inclination and elongated shape. The stability of Pluto's orbit amid these complexities is a testament to the intricacies of celestial mechanics. The three-body problem in space, involving how Pluto, Neptune, and the Sun interact gravitationally, is key to understanding this dynamic. Why no collision? Astrophysicists point to terms like mean motion resonance and orbital inclination to explain why Pluto and Neptune avoid a collision. At each point where Pluto crosses Neptune's orbit, it is positioned at least 90 degrees away from Neptune. This spatial separation prevents their orbits from intersecting. Furthermore, Pluto's vertical movement in its orbit means that even when it comes closest to Neptune, it is far above or below Neptune's orbital plane. This provides additional protection from potential collisions. Cosmic stability and the future. Despite these stabilizing properties, computational models suggest that Pluto's orbit is still somewhat chaotic. Minor deviations in initial conditions could lead to significant changes over centuries. However, gravitational interactions with Neptune, Jupiter, and Saturn keep Pluto on a stable path over incredibly long time scales. The possibility of a Pluto-Neptune collision remains highly unlikely, due to the precise gravitational choreography of the solar system. Yet, studying these interactions provides critical insights into how planetary systems form and evolve, helping scientists refine models for both our solar system and distant exoplanet systems. The potential consequences of a Pluto-Neptune collision. If such a collision were ever to occur, the impact would be catastrophic, not just for Pluto and Neptune, but possibly for the entire solar system. While both planets are relatively small compared to gas giants like Jupiter or Saturn, the energy released from such a collision would be immense. An impact could create a massive debris field that might spread throughout the solar system, with fragments potentially threatening other planets, including Earth. This scenario, although highly improbable given current orbital mechanics, highlights the interconnected nature of celestial bodies in maintaining the delicate balance of our solar system. What we can learn from Pluto's orbit. Studying Pluto's orbit gives scientists valuable insights into the broader mechanics of planetary systems. By analyzing gravitational interactions between celestial bodies, astrophysicists can refine their understanding of how stable orbits form and evolve over billions of years. This knowledge extends beyond our solar system, offering clues about exoplanetary systems in distant galaxies. The complex dance between Pluto and Neptune underscores the importance of long-term simulations in predicting celestial dynamics. The future of Pluto exploration. Given these findings, future missions targeting Pluto could unlock additional secrets about the dwarf planet and its surroundings. NASA's New Horizons mission provided stunning insights into Pluto's surface, atmosphere, and moons, but much remains undiscovered. Future missions could focus on precise measurements of gravitational interactions between Pluto, Neptune, and other planets. This data would help scientists build more accurate models of our solar system's formation and predict its future evolution. A cosmic perspective. Pluto's story is a reminder of the dynamic and ever-changing nature of our universe. From its discovery as the ninth planet to its reclassification as a dwarf planet, and now as a subject of fascination due to its complex orbital mechanics, Pluto continues to captivate astronomers and the public alike. Its unique journey demonstrates that even the most seemingly unstable orbits can achieve balance through intricate gravitational relationships. However, this balance isn't eternal. Over vast timescales, gravitational effects from other planets, passing stars, or even galactic tides could alter Pluto's orbit. Understanding these cosmic mechanics helps us appreciate the fragile equilibrium that keeps our solar system intact. As scientists continue to study Pluto and its celestial dance with Neptune, they unlock deeper mysteries about the universe and the forces that shape it, exploring Pluto's scientific legacy. Pluto's fascinating orbital behavior has reshaped how scientists view planetary dynamics. Its gravitational interactions with Neptune, Jupiter, and Saturn reveal how even seemingly chaotic systems can maintain long-term stability. This knowledge has implications far beyond our solar system, influencing how astronomers model exoplanetary orbits and search for potentially habitable worlds. Pluto also offers a unique window into the early solar system. As a Kuiper belt object, it preserves clues about the formation of planets and other celestial bodies. Its icy composition, complex atmosphere, and 5 known moons provide a laboratory for studying the building blocks of planetary systems. Challenges in understanding Pluto. Despite significant progress, many mysteries about Pluto remain unresolved. Its internal structure, potential subsurface ocean, and unusual seasonal changes are areas of active research. The New Horizons mission revealed a surprisingly complex surface with towering ice mountains, vast plains, and potential cryovolcanoes, features that scientists are still working to explain. Additionally, Pluto's thin atmosphere, primarily nitrogen with traces of methane and carbon monoxide, behaves unpredictably as it orbits the Sun. As Pluto moves farther from the Sun, its atmosphere may freeze and collapse, only to re-expand during its closest approach. Understanding these atmospheric cycles could shed light on similar processes in distant icy worlds. Future missions to Pluto. Given Pluto's scientific potential, space agencies are considering follow-up missions. Possible objectives include orbiting the dwarf planet, conducting detailed surface mapping, and even deploying landers or probes to explore its geology and atmosphere. A proposed mission concept, Persephone, envisions sending a spacecraft to orbit Pluto for several Earth years, allowing continuous observation. It could also investigate Pluto's largest moon, Charon, which may have experienced geological activity due to gravitational interactions with Pluto. Another exciting possibility is exploring the Kuiper belt more broadly. Since Pluto is one of the largest known objects in this distant region, studying it in detail could provide a foundation for understanding countless other icy bodies that populate the outer solar system. The broader cosmic perspective. Pluto's story highlights the dynamic and evolving nature of planetary science. What was once considered the ninth planet, then demoted to a dwarf planet, has emerged as a key player in understanding the complex gravitational web that governs our solar system. Its unique characteristics challenge conventional definitions of what makes a planet, sparking debates that continue to shape the field of astronomy. Pluto's reclassification also inspired the search for Planet 9, a hypothetical massive planet believed to lurk in the far reaches of the solar system, potentially influencing the orbits of Kuiper Belt objects. Ultimately, Pluto's journey from a mysterious in the sky to a scientifically rich world showcases humanity's relentless curiosity. As technology advances, future missions will undoubtedly unlock more secrets, deepening our understanding of this distant, icy world and the universe it inhabits.